Hello students, welcome back. Previously we discussed properties of zero, yes. And then we proved this one thoroughly. And we discussed the zero product property a little bit as well. Okay, some properties of 1. I think these are going to be easy to prove, so I'll leave those to you. Okay, let's discuss these. So x times negative y is equal to negative of x times y. Negative x times y is negative x times y, and so on. And then double negative, negative of negative x is x. As for the division version, these are just multiplying the reciprocal. So these 3 here are just repetitions of these 3, so they are not important. So basically there are 4 things to prove here. And then please remember, negative y is not defined as negative 1 times y. As a matter of fact, that's something you can prove as well. You can prove that negative of y is equal to negative 1 times y. Yeah, this one. Y equals to, so negative y equals to negative 1 times y. Yeah, you can set up and prove this one. So negative y, this one here is defined as the additive inverse of y. And negative 1 times y, this is additive inverse of 1 times y. So the left-hand side and right-hand side will turn out to be the same, of course, but they're defined differently. Well, if we have time to learn later, then we may come back and do that. But in any case, let's consider these. And by the way, what's the implication of those? Well, double negative coming back to positive, all right. And then here, one of the implication is positive times negative number is negative. Negative times positive number is negative. Here, negative number times negative number is positive. That kind of thing. So how do you prove that? Well, there can be many different ways, but let's start with this one. Negative of negative x is x. Let's prove that. First one. So we must prove the additive inverse of negative x is x. That's what you have to prove, right? Negative of something means additive inverse of this. So x is the additive inverse of negative x. So what's the additive inverse property? Plus something is equal to 0, and also that something plus the other way around. That's the additive inverse of negative x, isn't it? Alright, here's a property, additive inverse property, this one right here. So that's the additive inverse of y. Excuse me, here y is the additive inverse of x, but this time we are looking for additive inverse of negative x, so I put negative x in place of x, so y is a negative inverse. But then again, what I want is x, so okay. That's true, isn't it? This is true because x is negative inverse, negative x is the additive inverse of x. That completes the proof, actually. if I give you just a skeleton of all those, that completes the proof actually. Alright, so x is additive inverse of negative x, so adding these two of x plus negative x, and then the other way around, negative x plus x. Either way they have to be 0, but yeah, it is true because negative x is additive inverse of x. So okay, we got that. Which one shall we do next? This one? Okay, alright. What do you have to prove here? This is the additive inverse of x times y. That's what you have to prove. X times negative y that's the additive inverse of x times y. That's what you have to prove. So right inside is additive inverse of x times y. So this is the additive inverse of x times y. So what do we have to prove? This plus that has to be 0. And also the other way around as well. So x times negative y plus xy, and also the other way around as well, x times y we have to prove these two. Make sense? We have to prove that this is the additive inverse of this. So adding up, you have to get 0. That's what you have to prove. Let's see how to prove this one. Looks like that's not too difficult. I can factor x out. Because the distributivity property and negative y plus y, well, that's 0, isn't it? Additive inverse plus itself. And then we prove that x times 0 is 0 before. So we got this. How about the other one? Well, that should be this, excuse me, typo. That should be, oh, that should be the same as well. Factor x out. Y plus of negative y, and that's 0. So yes, they're both true. So they both add up to 0, one way or the other way. And that proves this is the additive inverse of x times y. Can you do something similar to this one? Very similar, so it shouldn't be too much of a problem. Okay, finally, how do you do this? Well, I'm very tempted to stop here and then ask you to complete. So we did this one. Yeah, that's a proof basically. And we did this one. Okay, these two. One direction, the other direction. And I think this and that are essentially the same because the only change here is change of character. And we can just rename the character without loss of generality, so no problem there. Okay, how about this one? What do we have to prove? Okay, Starting from the left hand side, that's negative of x times negative y, isn't it? By which property? By, let's see, yeah, by the first property. Wait. I'm changing, oh, by the second property. Yeah, that's what I used. Okay, y stay the same, so this negative y stay the same, and then negative x became negative of just x. All right, I just used this one. Okay, all right, and then let's use this one here. So negative of x, and then this negative goes to second number, so x times negative of negative y. That's what I just used. So instead of just y here, we started with negative y, so put extra negative there. We're almost there. Negative of negative y, what is it? That's y. So we have x times y, and it's not what we wanted. That probably is not the only way to do it. I used this one, and that one. I think I used that order, right? But you can change the order. You can use this one first, and then this one, and that one. Or they may be still different ways, of course. Ooh, we do have some time to burn, all right? So how about this? Okay, how about this? Negative x is negative 1 times x. So what do you have to prove? Negative 1 times x is the additive inverse of x. So if I add them up, I have to get 0. So x plus negative 1 times x has to be 0. Is that true? And also the other order. All right. Okay, let's prove that. That's the same as 1 times x plus negative 1 times x. Yeah. 1 is a multiplicative identity or the unity, so I can write any x as 1 times x, and then we can use distributive property. That is 0 times x, and that's 0 as desired. Can you do the same thing here? Yeah, just changing the order. That should not be a problem. And yeah, I'll leave that to you. Well, we did some many interesting things about sines and properties of rationals. I'll discuss those later, maybe in this video, or maybe just divert those to homework, maybe. In any case, for now, we are done with section 1.